12th of August 2026, the day the sun will disappear over Europe. The light will weaken, the temperature will fall, and across a narrow path the day will briefly turn into night. The strangest part isn't that the moon can block the sun and that's how we can observe eclipses. It's that from Earth they appear to fit almost perfectly. But this perfect alignment won't last forever. Before we get to the 12th of August, let's talk about what solar eclipses actually are. A solar eclipse happens when the moon moves directly between Earth and the sun. For a moment, one relatively small world blocks the light of a star more than 1,000,000 times larger. At first, it looks as if something has taken a bite from the sun. That bite slowly grows until the sun becomes a thin crescent. Even when only a tiny sliver of the sun remains visible, the landscape can still seem surprisingly bright. That thin crescent is so intensely luminous that it can continue to light the world and still damage your eyes if you look at it directly. It may feel as though the eclipse is almost complete, but it isn't. The real transformation begins only when that final piece of sunlight disappears. As the moon covers the final edge of the sun, the light doesn't vanish smoothly. The moon may look like a perfect circle from Earth, but its edge is covered in mountains, craters, and deep valleys. For a few seconds, sunlight squeezes through those gaps, creating a chain of brilliant points known as Baily's beads. Then only one point remains. The black disk of the moon sits in front of the sun, while a final burst of light shines from one side. Together, they form the diamond ring effect. And this is when the world begins to change fast. The remaining daylight collapses, colors lose their warmth, shadows become unnaturally sharp, and faint rippling bands may appear across the ground. In open landscapes, some observers can see the moon's shadow approaching, a vast wall of darkness racing across Earth's surface at thousands of kilometers per hour. The entire partial eclipse may have taken more than an hour, but these final moments happen in seconds. The last bead of sunlight disappears, and suddenly, day becomes night. With the sun's bright surface completely hidden, something normally invisible appears around it. The corona. This is the sun's outer atmosphere, a vast ghostly structure of superheated plasma stretching millions of kilometers into space. It's always there, but the sun's surface is usually so bright that the corona is completely overwhelmed. During totality, that glare disappears. The sky darkens enough for bright planets and stars to emerge. Red solar prominences may appear around the moon's edge, revealing enormous loops of plasma rising from the sun. The temperature on Earth can drop. Animals may begin behaving as though evening has arrived, and along the horizon, light may still glow in every direction because beyond the narrow path of totality, daylight continues as normal. That's what makes totality feel so unnatural. You are standing in daylight inside a moving shadow while the sun appears to have been replaced by a black disk surrounded by fire. It looks like a perfect cosmic alignment, but just how strange is it? Well, the sun and moon are nowhere near the same size. The sun is roughly 400 times wider than the moon, but it is also roughly 400 times further away. From Earth, those two differences nearly cancel each other out, making both objects appear almost identical in size in our sky. That's why the moon can cover the sun so precisely. But that fit is not always perfect. The moon doesn't orbit Earth in perfect circle, so sometimes it appears slightly larger and sometimes slightly smaller. Earth's distance from the sun changes too, altering the sun's apparent size. When the moon appears large enough, it blocks the sun completely and creates a total eclipse. When it's slightly too far away, it can't cover the entire surface. A bright ring remains around it, creating an annular eclipse, the so-called Ring of Fire. So this alignment is not some impossible coincidence, but it's remarkably precise. A small change in the size of the moon or in its distance from Earth, and total solar eclipses would not look like this at all. And eventually, they won't. The moon is slowly moving away from Earth. Not quick enough for us to notice, but fast enough to measure, about 3.8 centimeters every year. And it happens because of tides. Moon's gravity pulls on Earth's oceans, while Earth's rotation drags those tidal bulges slightly ahead of the moon. That transfers energy into the moon's orbit, pushing it gradually further away. In the distant past, the moon appeared larger in the sky. Total eclipses may have lasted longer and the sun would have been easier to cover completely. But as the moon continues to recede, its apparent size will keep shrinking. Eventually, it will become too small to fully cover the sun, even when its orbit brings it closest to Earth. Future observers may still see annular eclipses with a bright ring of sunlight surrounding the moon. But true totality will be gone. This will not happen for hundreds of millions of years, so there is no need to panic. But it means we are living inside a temporary cosmic window, a period when the moon is just large enough and just close enough to make the sun disappear perfectly. So, 12th of August 2026, the moon's shadow will sweep across the Arctic and North Atlantic before crossing Greenland, western Iceland, northern Spain and a small corner of Portugal. For most of Europe, including the UK, the eclipse will only be partial, and that difference matters. Even standing just outside the path of totality means missing the moment when the corona appears and daylight collapses. A nearly total eclipse may look impressive, but it's not the same experience. Spain will offer some of the most accessible locations, although the eclipse happens late in the day with the sun sitting low toward the western horizon. That means a clear, unobstructed view will be just as important as clear weather. And wherever you watch from, proper solar glasses are essential during every partial stage. Sunglasses are not enough, and cameras, telescopes or binoculars require dedicated solar filters. Most people will see the sun reduced to a crescent, but inside the path of totality, it will vanish. Its hidden atmosphere will emerge, and for few moments the sky will reveal an alignment that Earth will not possess forever. And if you're still here, thank you. If you enjoyed the video, consider leaving a like and subscribing. I know everyone says it, but it does really help my channel. You'll also find few astronomy and space related books linked in the description if you would like to support the channel further, along with more content at spaceopedia.co.uk. Thank you for watching, and as always, keep looking up.